So, on the bench today we have this very heavy speaker, and it is an ATC mid-range driver. If nobody knows about any ATC, they're a high quality speaker manufacturer. They've got a factory up the road from here, and they've been producing speakers I think since the 70s, and they will produce stuff that's normally used perhaps in studios at vast prices, and possibly for hi-fi if you've got enough money, which I haven't, because even second hand there'll be several hundred or thousands to buy. Anyway, my friend luckily lives across the road from ATC, and he uses some of their speakers in his sound system. And back to these things, he's got 4 of these mid-range drivers. Frequency response I think is 380 Hz to 3.8 kilohertz, and there's some information on the internet, and I think their nominal power is 75 watts, peak power of 150 watts. They're where's my ruler? Yeah, 3-inch soft dome drivers. That's the soft dome, obviously. And basic problem with this is the top's been off it, and I can remove it, being very careful, and then you can see the coil underneath, and you have to be so very careful when you take it off or put it back on again, because any damage or bending to the coil is going to give you a lot of problems. So, oh, nearly put it the wrong way up. Let's put it on its flange, like that. I think really, because it's been apart and in a workshop, when I looked inside the gap for the coil, and this weighs an absolute ton, it must weigh going on for 2 kilos, probably 10 pounds, really heavy. And main magnet there, with the magnet on the back. I can't really see what good the magnet on the back does, but must have some use. But I don't know if you can see down in the coil gap, there's, maybe you can, maybe you can't, I can see maybe a tiny bit of swarf it's got in there, and I can see some more down in that side. If I can get in there, yeah, you can see a little bit of something metallic, and that's why you have to be so careful when you've got speakers open like this. So, the method I've used in the past to get bits of steel out is find something thin enough, a thin enough piece of steel to slide in there and it will attract the metal particles, and you can get them out. So I'm going to try and find something, and also maybe a piece of cardboard just to go around and move them into position where I can get to them. So I'm going to see what I can find. So I'm back with a piece of cardboard, and I can see one of those little bits down in there, and I can move that right up, and I can just about see it there. I'm basically just going to go around, see if I can move any of those metal particles into a place where I can get to them. Not an easy job looking around the camera. That to me looks fairly clear. One little bit there I got out. Need perhaps a small screwdriver. It's a bit of a long and tedious process, because sometimes they stick to the screwdriver and sometimes they don't. I've got one there. Just go around with the card again. Maybe I'll double it up. But of course it won't fit doubled up. Yes, it will. I can still see little bits. I think I've got one there. I can see one down in there. Problem is, you're trying to use metal tools, steel tools, and they're impeded by the magnet. And there is one there. Got that one. I think that's not far off being fairly good. I think it's as good as it's going to get anyway. Got another one. Alright, so that's done, I think. So now the hard bit, getting the coil back in. I just remember what I said earlier, 2 kilos I think. No, I reckon these are 4 kilos, which should be more like £10. 4 or 5 kilo in weight. So now we're going to try and get the coil back in and try and get it central. And also lined up with the holes, which I have done, I think. Now we can connect the signal to it. But before I connect the signal, I want to check its that's DC resistance. Make that stay on, and it's coming out at 7 ohms, if you saw that. 7 ohms, but of course that's DC. The coil will have it inductive reactance, and my LCR meter will actually measure impedance at 1 kilohertz or 100 hertz, but we'll do it at 1 kilohertz. if I can get everything lined up. So turn that on. It says it's 7.9 ohms and it's Z 8.3 ohms. Impedance at 1 kilohertz, 8.3 ohms, which sounds good to me. Enough of that. So now we'll connect a 400 hertz tone at I think 1 volt, might be a bit loud. That sounds okay, but you can definitely hear as I move. Too loud. If I move it around, I'm looking for the clearest tone, and I reckon that's the clearest tone. I turn the gain up. I know it's really annoying. Enough of that. I think it's time to put the bolts in before I do any final adjustments. So bolts are in, and of course that upsets its orientation slightly. It's going to slowly tighten them down. I hope it's not too annoying this time. See, that upsets it, that does. Okay, so I've now got it on 1 kilohertz and it sounds fairly okay. I'll take it up a bit. That's a volt. Really annoying, I know. I wonder what it looks like on the oscilloscope, and if you can see any distortion being created on the waveform. Of course, what you're supposed to do the job properly is take the dust cap off and shim the coil inside the magnet so it's perfectly central. Anyway, let's get the scope connected up. Okay, that's what it looks like on the scope. It's like a nice clean sine wave, no distortion. Okay, what else should we do with it? Because I think it's fine. I could put some music for it, but I know it's really annoying noise as well. I could sweep it, I suppose. Let's try sweeping it. Okay, I'm going to sweep it from 300 hertz to 3.8 kilohertz. Just go ahead. Might be very annoying. 300 hertz going up. Okay, that's enough of that. I think this one's done. I could use I should have done it before I put it back together. I should push the dent out, but I can do that with a hoover on a low power. So that's an ATC mid driver, and I got 3 more of these to look at, which I won't bore you with now. So that's the end of this video. Thanks for watching. Bye for now.